Hello, welcome to this unit on deduction and induction. These are two reasoning mechanisms that we commonly use, and we'll talk about how this fits the framework eventually. So stay tuned. I hope you like this. Okay, so in this unit, video lecture, we'll try to answer this question, why we need to use the formal rules for reasoning. And in reasoning, we'll talk about deductive, inductive kinds of reasoning, and we'll talk about the formal logical rules specific to this. Then we'll move on to talk about specifically different types of deductions in the context, in different contexts in which you use deductions of the sort where the statements are of linear ordering type or conditional type or a specific syllogism type. Then we'll talk about the barriers to critical logical thinking and the take-home message. So let's first get started with um, why formal logic and what it is. Okay, so just to give you an idea of what we're dealing with here, we're talking about reasoning. Okay, now when you hear the word reasoning, this is hallmark of human thinking. So the fact that we are at a higher level in evolution is because we can think reasonably or we can reason through information. Now, what is reasoning? In a more colloquial fashion, reasoning is talking about what follows from what. Okay. So you have, say, two statements, statement one, statement two. Let's say first statement is all humans are mortal and the instructor is human. Then the conclusion you can draw is that instructor is mortal. So reasoning is a process of going from one information or set of informations to new sets of information or new information. In doing so, you are supposed to use the rules of logic. And so the conclusion you're drawing here is basically an inference based on the available information. So you have two statements. One is about humans and the other one is about the instructor. And based on these two statements, you are making the inference that the instructor is mortal. And none of these two statements carry that information. So generating this new information is a reasoning process. In that sense, it is an inference generation derived from two or more statements. Now, that is one way of looking at it, right? And in that sense, when you're inferring something, you're creating kind of a belief. So you can also call this as inferential belief. And it's important for us to understand because we'll talk about fallacies and we'll refer back to this belief thing. Now, it is also important for this class because critical thinking, right? And when we first talk about general definitions, we said there is no particular specific definition, but there is some common understanding about what entails critical thinking. That definition, interestingly, has this construct in it, where the ability to reason is considered as an important skill to be a critical thinker. So reasoning then is generating new information from the existing information based on some standards. And this information that you have inferred is called a conclusion. And the information that you're basing information on, the existing information, are called premises. So this you might have heard. Premises, the first two statements of premises, and the information you're generating, the inference, is called a conclusion. And you're using some standards of going from here to here, and these standards are supposed to be based on the rules or laws of logic. Okay. Now, what is logic then? Logic is a branch of philosophy, right? And that explicitly states, right, the rules for drawing conclusions that are correct, and we use the word valid conclusions. A correct conclusion is a valid conclusion. So this branch of philosophy called logic, it lays down specific rules explicitly for us, rules that will help us make valid conclusions, correct conclusions from the existing premises. So according to the rules of logic, the conclusion, let me clear this. So you have premise one. Again, this is one kind of deductive reasoning, right? We'll talk about the other kinds. This is a conclusion, right? So a conclusion, according to the rules of logic, is a valid, okay, if this conclusion follows necessarily from the premises. So if P1, premise 1 and premise 2 are there, conclusion is supposed to be true or valid. I take back the word true. So premise 1 is that all humans are mortal. Premise 2 is this instructor is human. If these two are true, and we assume these are true because This is about the validity, which is different from the truth value. And we'll talk about what fallacies people encounter when they read reasons of this type, reasoning statements of this type. The conclusion should necessarily follow means that the conclusion has to be true no matter what. Only then will the conclusion be called valid. So, what is that one conclusion you can draw about humans and what do you say, instructor and models that is true no matter what, assuming that these two premises are correct? And that would be that the instructor is mortal too. This conclusion is a valid conclusion because it follows necessarily from the given information. And these two earlier information statements are called premises, and this conclusion you've drawn is called a valid conclusion. If the conclusion does not necessarily follow from the premises, then you call that an invalid conclusion or illogical conclusion, just as you can call this conclusion valid and logical conclusion. Okay, so let's look at another example. Let's say the other example is that humans are crazy. My dog is a human. My dog is crazy. Let's change this crazy to mortal. Okay, or let's leave it like that. Okay, now is the conclusion valid? Okay, the premise is humans are crazy. My dog is a human. My dog is crazy. Is it not same as humans are mortal? Instructor is human. Instructor is mortal. But it's kind of hard here to kind of conceptualize that and go through it. You get stuck, right? That's the problem with humans. With us, psychologists that who are interested in how people reason, they look at how people use logic when they actually answer or go through statements of this sort. One thing they realized is that just so you know, the truth and validity are two different things, right? Even if the premises are not true, we assume that premises are true. And in reasoning task, you have to decide if the conclusion follows from the premises. Okay, when that is the ungiven information that these are assumed to be true, you should not be worried about whether they are actually true or not. So in that sense, this is a valid statement. But what happens is that people, when presented with not necessarily true premises or a true premises that is against their own beliefs, they get stuck. Okay, that's one thing we have learned about reasoning task is that people get lost in the content of it, content or the topic of the reasoning, and get lost in it where their beliefs takes over. So in everyday tasks, then we get lost with the content and do not necessarily look at the logical rules that need to be applied to make valid conclusions, right? Instead, what we try to do is we try to change the statements, either the premises or the conclusion, to match our beliefs. So the rules of engagement are not based on the rules of logic, they are mostly based on some personal rules, right? So that is a problem with logic for humans, and we'll talk more about this and the limitations of logic in the next slide. For now, let's move on to talk about why logic. I gave you some information now, but we'll talk a little bit more in the next slide. Okay, so coming back to our first question, we said why use formal logic? Well, just you have seen earlier, humans are not good using the rules of logic because they get lost in the content. What the branch of philosophy, the logic, does is that it provides a language to separate the content from the structure, so you don't get lost in the context, the world context about the dogs, humans that we looked at the example earlier, versus a language that uses more abstract terms about A, B, and, or, nor, exclusive, inclusive, and whatnot. So the rules of logic provides us with the linguistic tools to overcome the biases that we experience of getting lost in the context of the words used in the reasoning tasks, which will help us avoid some common errors. And it also help us to view the reasoning problems in a more unbiased third-person perspective that will allow you to apply these rules in a more objective way. Okay, so to build on what we discussed earlier about how people are not good at reasoning tasks, and one thing we said that people often, so these are the difficulties people have with formal logic, is that they often do not apply these rules because they get lost in the content and they may know the logic of the logic or the rules, but they fail to apply it. So people tend to use kind of pragmatic rules. There are logical rules that you need to use, but we usually don't need to use those in the everyday context, right? Because everyday context, you counter statements that are true and work with them, right? So we kind of use pragmatic reasons as opposed to the logical reasons, and that's why we are not good at it, right? What researchers have found is that we can change this. Another thing that we cognitive psychologists found was that when the reasoning task asks questions about whether the conclusion is true or not, instead of that, they ask, what is the likelihood of the conclusion being true, right? In such instances, people start actually using logic more than if the task was to just see if the conclusion was valid or not. Okay, so that's one thing we found. The other thing is, um, what do you say? The other thing is that if people are trained in formal logic, then that also helps them. Okay. Another way to look at it is the use of system one and system two thinking. In our day-to-day life, we tend to use our system one thinking more than system two thinking. That's why for some reasoning tasks we're really good, the answer pops out and we know what the answer is. But most of the reasoning tasks are not that easy, and we have to somehow stop our system one intuitive thinking, and because it will be carried away by the belief system, right? So it's like the reason and logic and belief, they are collided, and you're supposed to use logic, but your belief comes in because the statement doesn't seem to be true, doesn't fit your belief, right? So how do we do it? Well, we can train ourselves so that you can learn to slow down and start using logic. And through practice, what happens is that you start to use logical thinking more than personal beliefs. And with more practice, it becomes automatic. So you become a system one logical thinker. Does it make sense? So it doesn't happen overnight. You have to deliberately start using logical rules and not the beliefs and biases that control our reasoning. And over time, with enough practice, that becomes automatic to us. One example I would give is that if you've taken logic or logic related courses from the philosophy department, you talk to your philosophy professor about logic and the things, they are like this, right? They're very fast. They think those in terms because they are more experienced, right? And they have taught it so many times that it has become system one thinking for them, right? So that's why you can think of yourself about how you were thinking in the earlier weeks of that logical class courses that you take in the philosophy department, and towards the end of it, you can see how you are stuck. Now you get less stuck, and you become more aware of it, and take multiple courses of that sort and courses like these that will give you a metacognitive awareness of the processes that you go through. Then over time, your system one thinking, your reasoning would become a part of the system one thinking. That's one difference between experts and novices, not only about logical thinking, but thinking in general. Why experts are better is because they go through this thinking over and over again, and every time they go through it, there are some checks, it's verified, they're given feedback. All this over time leads to quicker thinking in the field that you have expertise in. So take more classes on this topic. The more you practice, the better you become. Okay, so let's talk about the deductive reasoning first, then we'll talk about the inductive reasoning. So deductive reasoning is going from general information to specific information. So you use the information like statement one and statement two, which are called premises, general information that is assumed to be true. And you're going from general, like principles or thing. Now, based on these, what kind of inference can you draw specific to an instance? So going from general principles related to, let's say, people in general, to making a specific conclusion or inference related to one instance. So you have rules, and based on those rules or principles, general principles, and you're trying to apply that to a specific instance and draw an inference. Okay, so we talked about how all humans are mortal, right? And the second general principle is, again, general principle or given fact is that Socrates is human, right? Then the conclusion you draw is that Socrates is mortal. Now, this conclusion follows necessarily from the premises. So, such way of making inferences where you go from general information applied to specific instance is called deductive reasoning. And guess who is better at it? Good at it, Sherlock Holmes. Now let's look at some examples of it, or just one example of it, right? Every cat has four legs. So that is premise one. This animal here is a cat, premise two. And the conclusion, the inference you're drawing is therefore this animal has four legs. So you're going from given general information and you're drawing a conclusion specific to this animal. So every cat has four legs, the general premise, right? This animal is a cat is a fact. You're using this general given information to make an inference that this cat has four legs, given it is an animal. So that is deductive reasoning. The general form of putting this is using abstract terms. That's what the formal logic does. All A's are B's, all B's are C's, and therefore all A's are C's. So it belongs to this particular rule. Another example, death penalty is cruel and unusual. Premise one. Death penalty, punishments of this sort, right? Such punishment is unconstitutional. Therefore, death penalty is unconstitutional. So death penalty is cruel and unusual, and such punishment, meaning cruel and unusual punishment, is unconstitutional. Thus, death penalty unconstitutional. So, given that conclusion follows from the premises, you say that's a valid thing. Okay, now let's pause here. Now let's quickly review the terms that we learned in the context of deductive reasoning. We talked about premises. Premises are factual statements that we'll use to draw conclusions, right? And conclusions are the inferences that you draw from these factual statements. So factual statements and the inferences you draw are the conclusions, and these form the basis. So you may form beliefs based on these inferences you've drawn, or these are the inferential beliefs you derive from the premises. And validity has to do with whether the conclusion logically follows from the premises. If it does, it's a valid conclusion. If it's not, then it's an invalid conclusion, right? Or a valid conclusion is also called a logical conclusion. An invalid conclusion is also called an illogical conclusion. Okay. Now here in the next slide, we'll talk about how this has to be separated from the truth, and we'll talk about that in the next slide. Okay, so validity and truth are two different things, and in deductive reasoning, your task is to check the validity of the conclusion, whether the conclusion follows necessarily from the premises. In that is this assumption that you're not looking at the truth value of the premises. Although we say that the premises are factual statements, we assume that these are factual statements to use the laws of logic here. So validity and truth value are two different things. Okay, validity is concerned only with the logical structure of whether the conclusion follows from the premises. Under that is the assumption that it is true. And you're not thinking about the truth, you're just asking yourself, if these premises were true, would the conclusion necessarily follow from these premises? So the premises are treated as facts regardless of the real world truth about it. So you need to make that distinction. At the same time, you also have to make the distinction about the truth, your beliefs about the truth, and your opinions about the statement. You have to stay away from those. Okay, now coming to inductive reasoning. Again, in the previous one, I had said that Sherlock Holmes is good at deduction. Well, he's good at both. And actually, the deduction and induction are the two forms of reasoning that we interchangeably use in different contexts. So no thinking is purely one or the other. Okay, this is just to kind of give you some real life examples. But yeah, so coming to inductive reasoning. So this inductive reasoning is reasoning from specific examples to general principles. So remember how in deductive reasoning you have general principles and you are inferring in the context of a specific situation, right? So if you think about generals and specifics, you're going in this direction, going from general to specifics. In inductive logic, it's opposite. You go from specific observations and you make a general conclusion. For instance, you have observed all your life that the sun rises from the east. Okay. Now, can you draw this general conclusion then that based on all these observations all my life, you conclude that the sun will rise on the east? Such a conclusion would be called an inductive conclusion. Now, you have to keep in mind there is no guarantee that the same thing will gonna happen unless you have some explanation, which will not go in detail about it. But it is possible that the sun may rise totally in opposite direction for one or the other scientific reason. We're not going talking about the reason here. So your conclusion is not, structure wise, is not necessarily true. Meaning just because you have sun coming from the east side every day, it does not guarantee that you'll have sun rising on the same side the next day. Let's take another example. Let's say you have experienced people to have one head all your life. Okay. Now you went to an island and you conclude that, what do you say? And you're making a general conclusion that all humans have one head, which might be true, but it is only true till you experience an observation that counters it. So you can never prove in inductive logic, you can never prove that your conclusion is correct just because it had happened multiple times in the past. You cannot make a conclusion that it is necessarily true. You can only make conclusions that are probabilistic. You can say that it's more likely that humans have one head. It is more likely that sun always rises from the east. Does it make sense? Okay, so conclusions are probabilistic, not guaranteed. So if you think about it, in deduction, you have general information, which are like theories, hypotheses, right? And from these, you are drawing uh, um, conclusions, right? And that would be deductive logic. Inductive logic is you're growing up using observations to make general information. Now, I want you to keep in mind that science uses both the deductive and inductive logic in a way that it supports and generates theories. So it is trying to develop theories, but it is testing its theories by using deductive logic. So it's both. You have to keep in mind. So as to kind of Okay, so that point is emphasized here, where Einstein says all of science is nothing more than a filament of everyday thinking. The idea is that everyday thinking has both deductive and inductive reasoning in it. It's not just one or the other. Okay, now coming to types of deduction, and specifically we're talking about the context in which the reasoning of deduction kind, where you go from general to specific, are used, or in tasks related to linear ordering, tasks related to conditional statements, tasks related to syllogisms. And we'll talk about briefly about these three things, but I want you to go back to and read the chapter on these topics. There'll be a few pages, but they're very, very good information about it. So make sure you don't miss that. A technique to kind of help you answer linear ordering questions or linear syllogistic questions. First thing I said is draw a line. It doesn't matter if it's horizontal or vertical. I prefer vertical, but doesn't matter. Okay. This is about the characteristic that is being compared, the strength. So let's say this is strong, more strong. Let's say this is less strong. And let's consider all these individuals whose strength is compared. Joel, Bill, Richard, and Donald. Okay, now let's try to put the factual information provided in each premise on this diagram and see how it helps us. Joel is stronger than Bill. Okay, so Joel should go up and Bill should go down. So randomly pick a position that says Joel's. He's stronger, so towards this side than Bill. So Joel is stronger than Bill, but not as strong as Richard. So Joel is less stronger than Richard. So Richard can go here, right? Now let's look at the next one. So that's how you can represent the information presented in premise 1. Let's look at the information presented in premise 2. Richard is stronger than Joel, which is already represented here, right? But not, I'm sorry, the not part is missing there. But Richard is not as strong as Donald. So Donald should be above Richard. You double check the relationships if it's correct, and if it's correct, you have represented the problem. You can just answer the conclusion. The conclusion is not given to you, then you have to draw the conclusion. Who is the strongest and who is the second strongest? And that conclusion you draw about who is the strongest, second strongest, should be necessarily true if these statements are true. Okay, assuming these statements are true, what is necessarily true about the strongest person is Donald. Second strongest is Richard. So this is how using linear diagrams would help you answer questions, reasoning questions better by using linear diagrams. Okay, so now that we talked about linear syllogism, it's time to talk about the second kind of deductive reasoning called the if-then statements. It's also called contingency syllogism. So just like the other deductive reasoning problems, here you have premises, then you have the conclusion, and in the linear order syllogism, these premises were factual statements about the linear relationship between some entities, right? Here, for the conditional, it's also called conditional logic. In these kind of contexts, the premises are about the conditional or contingency statements about or facts. So, and instead of the linear relationship, these premises are about the contingency relationships. Contingency relationships imply that something needs to happen for something else to happen, meaning the true nature of an event will depend on another event that precedes it. So that's why it's called contingency relationship or conditional. And usually, in general terms, you use the term P and Q to refer to it. If P, then Q. And P is the antecedent of the contingency, and Q is the consequent of the contingency. Okay? Antecedent and consequent. Antecedent. So the statement is these premises are stated in these ways. In this way, if antecedent, then consequent. If P, then Q. Okay, let's look at an example. Let's say the example is if she is rich, she wears diamonds, right? So rich is the antecedent, wearing diamonds is the consequent. Now that's the first premise. Second premise is she is rich, A, and the conclusion is she wears diamond. Now is it a valid conclusion? That's what we'll talk about. How do you determine validity of the conclusion or the inference based on the premises? Again, you're going from premises to determine the true nature of the conclusion, the validity of it. And we'll take an example in the next slide. But here is the best way to do it. The if-then statements can be answered better by using what is called as tree diagrams. And let's look at the same example. And again, by the way, this example is in the book chapter. Make sure that you review it. So as we discussed earlier, right? If P then Q, one example is if she's rich, then she wears diamond. She's rich, she wears a diamond. Is it a valid statement, a valid conclusion? So the first two are the premises. The third one is a conclusion. To do this, let's use a tree diagram that has two components to it. One is the dot called a node and the lines that come out of the dot called branches. Dot represents the point where you are, right? And branches represent the possible states of outcomes. Okay, let's look at one example here. And again, so you start from the starting node, right? First, you talk about the antecedents, then you have states of consequence. So let's look at if she is rich, she wears a diamond, right? You start here and you talk about antecedents. So what is the antecedent? Antecedent has to do with whether or not she is rich. And this antecedent has two possibilities. Either she is rich or she's not rich. So these are two possibilities. So for the antecedent, there are two possibilities at the start node. One possibility is that she is rich. The other possibility is that she is not rich. Let's talk about the consequence. If she is rich, what is the consequence? Well, based on the premise that if she is rich, then she wears diamond. So this branch ends in only one possibility outcome and one possible outcome, and that is she wears diamond. Okay. Let's look at the other possibility related to the antecedent. Let's say she's not rich. Okay, would she wear a diamond or would she not wear a diamond? Well, this information is not provided to us. So we would assume that if she's not rich, she could either wear a diamond or not wear a diamond. So those two possibilities. Now let's try to see how to answer questions of this sort using a tree diagram like this. So if she is rich, then she wears the diamond. So where are we here? So this is the whole statement, right? Let's talk about the second statement. This is the most important thing, the second premise. So second premise is saying she is rich. Where is she? Is rich. So you are here. When you are here, there is only way you can go forward, that she wears the diamond. Let's say what the conclusion is. She wears a diamond. She is wearing a diamond. So this conclusion is a valid conclusion if it starts from here. Let's look at the second one. If she is rich, then she wears a diamond. Fine. She's not wearing a diamond. Let's see where we need to start here. Remember, not wearing a diamond is at only one place. And if you go back and trace the antecedent. There is only one possible antecedent here for not wearing diamond, and that is she's not rich. So if you get a statement like, if she's rich, she doesn't wear she's not wearing a diamond, she's not wearing a diamond. Okay, that means therefore she is not rich. This is also a valid conclusion because there is only one path leading to here. Third possibility is, if she is rich, right? And I'm going to, if she's rich, she is wearing a diamond. She is wearing a diamond. And you can see that there are two possibilities of wearing a diamond. And given there are two possibilities, right? Let's see what the conclusion is. She is rich. Well, you can go to the antecedent of rich or not rich from these two different states, meaning that the individual may be wearing diamond because she is rich or not because she is rich, or she could be rich or not rich. So this is not a valid statement. This is not a valid statement. This is a valid statement. Let's look at the last one. She is not rich. So you're starting from here. If she is not rich, what is the possible status of wearing a diamond? Well, there are two possibilities. She could either wear a diamond or not wear a diamond. So you cannot make a specific inference that is necessarily implies from these statements. So it says she's not wearing a diamond. No, this is just one possibility. She could also be wearing a diamond if she's not rich. So that's how you need to proceed. The general idea is to draw something like this. Let me clear this and see if I can redraw. Maybe not. The way I would do is kind of start with the start thing, right? A start node. In the start node, you have to first have, if PQs are two possibilities or two branches, one branch, each branch represents the possibilities of the antecedent. So antecedent, the P part, okay? One possibility is there is antecedent, the other possibility is there is no antecedent. Then if it is antecedent, right, there is only one possibility. If rich, then diamond, right? So that is the consequent. If there is no antecedent, meaning that if she's not rich, there are two possibilities. She could either be wearing a diamond or not wearing a diamond. Now, this would be a general structure that would apply to all if P then statements. In fact, there is a pattern to it, and these patterns are given names. Only valid ones are these two, right? Where the names that are given to these kinds of syllogistic reasoning are based on whether the antecedent is affirmed or denied. Affirming meaning that it is antecedent is yes, denying is no. So first, let's look at the first one. The second premise says that she is not rich. She is rich, sorry. Rich is the antecedent, and it is affirming the antecedent. It is affirming the antecedent. So it is saying it is A. Denying the consequence is the second one, because she is not wearing a diamond. So we start from here. This is not wearing the diamond has only one possibility. So this is called denying the consequent. And this is called affirming the consequent, because the second statement says she is wearing a diamond. And here you're denying the antecedent because you're saying she's not rich. Again, it needs more practice to kind of internalize this again. And the moment you practice more, you will get used to this and it becomes more automatic to you. Okay, so I want you to really work on this problem called the 4-card selection task. Now, I will add a separate video or make it as a part of an assignment to kind of talk about this. Okay? And also, I'll do the same for the other kind of syllogism or the other kind of deductive task, because there are more things I want to discuss, and we've already close to an hour on this video lecture. So I'll have a different set where we only talk about different types of deductive reasoning, because there are a lot more than I can in this short lecture. Okay, so the syllogisms are the ones that we first discussed about all A's or B's, or all B's or C's and all A's or C's. So stay tuned to that. We'll talk about it in a different set of video where we only talk about deductive reasoning, because it has become a too long one already. Okay, so let's talk about the barriers to logical thinking. What are some things that will prevent us from actually using the deductive or inductive reasoning where we don't use the logical rules? So let's talk about that in the next slide. Okay, what are some barriers to using logic? As we discussed earlier, we talked about how we alter the premises if they don't fit our beliefs. That's one common problem. Barrier is to inability to get over our beliefs when reading reasoning problems. If it doesn't fit your belief, people tend to change it, right? The other one is that people are related to the same thing, because people get carried away by the content, meaning the context or the material that is being used, the context in which it is used, it will override the formal logic, right? So practical goals override the formal logic. It's related to pragmatics. People use more personal belief based logic called personal logic. So those are some barriers. Again, we will make another one where we talk about some of these things. Okay, so now we are on to the last outcome for this video lecture, where we will talk about some key take-home points. We've discussed that learning formal logic, right, is important. And this acts as a cognitive tool, right, that kind of gives you better understanding of the structure of reasoning, and it gives you this language free language or the content free language, where we talk about abstractly the rules, like if p then q, all those rules will get internalized if you learn more and practice more. And we also discussed two types of reasoning: deduction and induction. We said that deduction guarantees the conclusion, whereas induction, it doesn't guarantee a conclusion, it supports the conclusion, or it provides the probable support to the conclusion. Then we said that there are different types of deductions depending on different reasoning tasks and contexts. And we also discussed how real world thinking is not one or the other, it is a blend of both logic, of both deduction and induction. And also people in real world use their personal beliefs and also use personal logic and pragmatic factors. So yeah, just be more aware of these and practice more.